Because the Webb telescope is too large to fit into a rocket, engineers have designed it to unfold in a kind of origami-like fashion when it gets into orbit. That goes for the mirrors on the observatory too. The primary mirror that collects light from the cosmos, well, that light then bounces up to the secondary mirror before making its way to other mirrors, and eventually ending up into the cameras. We're here at NASA's Goddard Space Flight Center in Greenbelt, Maryland, because the deployment of the secondary mirror is about to happen. So Adam, how do you guys get the secondary mirror into position?
Well, we deploy 3 struts that are much like a tripod, and the secondary mirror will sit atop above the backplane.
So how important is this test?
Well, this will be the first time that we are deploying the tripod with a secondary mirror installed. As with anything on this project, every test builds upon another. So we want to be able to master this test and be able to perform it again when we get to the flight hardware.
Well, can we take a closer look at what's going on down there?
Absolutely. Let's head into the clean room. You'll see the tripod come into place, just as I was saying, upstairs. Now, 2 of the struts are the same, but one is actually different in the sense that it has a hinge and it folds underneath when it's stowed. The entire observatory must be folded up so it fits into Ariane 5.
So the way you're doing this test right now, this is not exactly the way it's going to be in space, right?
Yes, absolutely. This yellow tower effectively creates a zero-G environment in the sense that it doesn't allow the mid-hinge to close on its own when gravity takes over. We want to be able to control every aspect of the operation and that closing of the hinge. Well, Mary, before the deployment is complete, how about we go upstairs to get a different perspective? But first we need to put these blue masks on because we'll be in such close proximity to the mirrors.
Okay. How big are these struts anyway?
The distance between the center of the backplane and the secondary mirror is about 25 feet.
So that's like a 2-story house or something.
That's probably a very good comparison.
How strong are these struts?
These struts are very strong to withstand the stresses of very, very cold temperatures of space. They are hollow composite tubes, and the material is about 40 thousandths of an inch thick.
So it's not very heavy?
No, they're extremely light, but they're also very strong.
How precise do you have to be with the positioning of that secondary mirror?
Each time we deploy the secondary mirror into the same position that it will be in space, it is within 1 millimeter every time.
Well, thanks, Adam, for helping us understand more about how the secondary mirror will be deployed.
Thank you. It was my pleasure.
The deployment of the secondary mirror happens on the 11th day after launch and is one of the last steps the Webb telescope goes through before it's considered fully deployed. Thanks for joining us for this edition of Behind the Webb.